turn it over now to Mr. John Insworth, who's going to tell us about some cool stuff.
All right.
How you doing?
So for about the last year or so, we have tried out doing little news updates before the main speaker. So you get a warm-up act, and that's me. I try to pick stuff that hits the news or is really significant in the last few months. And just in the last few weeks, announcement that biological materials announced on Mars came out of NASA. So if you think that we've now have aliens looking back at us from Mars, I want to clear that up. So here is the Curiosity rover. It's about the size of an SUV, driving around on Mars, doing it very slowly. It is in Gale Crater. We'll take a look at Gale Crater in just a moment. But it's been roving around, taking measurements of the air and the environment, the soil, the rock, for about 6 years now. One of the instruments, and the one that made one of these discoveries, is this contraption here called the SAM instrument. It's part of a drill arm thing that brings soil or rock samples in, puts them into a limited number of little cooking chambers, and they can heat them up to a specified temperature, and then they can see what comes off of that. So if there are tiny little Martians running around, they could get scooped up and cooked. So it's a horrible first way to meet alien friends, but probably not. This allows the rover to sample below the surface, because without an ozone layer and very thin atmosphere, there's a lot of ultraviolet light from the sun that cooks the surface. We also have chemicals called percolates or perchlorinates that are caustic little molecules that can be fantastic at killing microbes. So the surface, the very surface of Mars, is sort of self-sterilizing. But if we go a little below the surface, maybe we can find something else. And that's the intent of this function of the rover. The samples that everyone's talking about right now were actually taken in 2015. They drilled into the rock. They can only go a limited distance in and pull out some undisturbed material from down below. And what they found were complex organic molecules. So these are molecules involving carbon and rings and segments that are found in organic materials like life. So that is right there very interesting to scientists. This whole region is believed to have been an ancient lake. In early Martian climate, there were rivers, rainfall, and possibly an ocean that covered most of the northern hemisphere of the planet. But these little complex organic molecules can also arrive by meteorite or meteor. And so we see them coming down. We can measure them from the meteors that we pick up, meteorites that we pick up on the ground on Earth. There are also volcanic processes that can make complex carbon molecules like this. So it doesn't definitely mean that there ever was life, even bacterial level life on Mars. But if it isn't evidence of life, it does show that evidence of life could be preserved in the subsurface material on Mars. So that's significant. It says this is worth still looking for, and it's worth coming up with other avenues of investigation that would prove yes or no that this is part of an ancient life cycle of some type. This material is very rich in sulfur, which helps preserve it. If it turns out through further investigation and other experiments that this is the remains of ancient biological life, it would be similar to what we call on Earth kerogen. And again, we find kerogen on meteorites as well. And the European Space Agency's ExoMars rover, which is going to launch in about 2 years, will be able to drill deeper and look at this more closely. So kerogen is a solid organic material found in sedimentary rocks, and that's what most of the region is that Curiosity is going through. We have a lot of it on Earth. In fact, there's more kerogen carbon on Earth than there is life, living stuff, by 10,000 times. And when you heat it, you can get these interesting chemicals off of it. This kerogen can become petroleum and natural gas on Earth, and it could come from algal or terrestrial life or marine life in the past, or not. So we'll see. So here's the Gale Crater. This is the region that the rover can easily photograph. There's a view from behind. You can see its tread marks in the Martian soil. I mean, doesn't that look like maybe Nevada or New Mexico or something? I mean, it looks homey. I'd love to be there. Here are some mineral veins that Curiosity saw as it was passing. This is a type of mineral formed with prolonged exposure of water to the soils like that seen on Mars. So further evidence this was a place where water sat for a long time. The other announcement that is also interesting when you're wondering about life on Mars is methane. Clouds of methane seen in the atmosphere of Mars. And we see in the summer about 3 times the methane amounts that we see in the winter, which, you know, on Earth, when summer comes, everything livens up and lives and grows. So that's an interesting cycle. Before these measurements from Curiosity, it kind of looked random. And if it's random, then it's probably just some geological interesting thing, but less likely linked with life. The methane breaks down again pretty easily with ultraviolet light, so it doesn't stay in the atmosphere very long. So when it's emitted from someplace, you can see where it's coming from. You can get more of a clue as to where that, what might have produced it. If it's just in some highland volcanic area, that'd be significant, opposed to some lowland area where you have a bunch of sedimentary rock. On the bottom, what was once a lake or a sea of some kind. So we want to know, where is this methane coming from? On Earth, the main producers of methane are termites and cows tooting out in the field. That's 95% of the methane in the atmosphere. So, you know, here on Earth at least, when we see methane, we know that something alive probably did it. But weathering of Martian rocks, also methane trapped in ices that are melting on Mars, would be non-biological sources. So coming to the rescue is the just turned on, another European Space Agency mission, the Trace Gas Orbiter. It's just started taking data. Best I can tell, these graphics here are simulations of what they expect to see. They are not going to release data until this fall. But what we'd like to see is a subsolar point where it's warmest, activating some little microbes down in the permafrost below the ultraviolet light and the perchlorates on the surface, and you would get the methane seeping out. We'd like something like that. Or if we knew the mineralogy of a region and we could map that to where methane was coming from and not, that'd be great levels of evidence to work with. And that's what's going to be coming soon, this year. All right, so we've got to wait for 2 European Space Agency missions to answer those questions. We don't have microbes that we know of crawling around on Mars. We don't have life off Earth yet, but we're looking. But here's some nice pictures of Mars. So here's some Mars color and stereo surface imaging of some parts of Mars. Let's take a look at another shot here. Here's from Curiosity again. And that looks very inviting. So this is down where there was water. Those are sedimentary rocks. There's another selfie. Curiosity likes to take selfies. So someone gave it an early cell phone, I think. And there's another picture. You could tell that someone, oh, that's in Morocco or something. I mean, it looks really iconic. This is Mount Sharp. All right, so thank you very much. Any questions about Mars and life? Any questions? No? All right, well, if we give us a moment to change clickers and microphones, Andrea is going to introduce our main speaker for the evening.
John, that was great.
Thanks everybody for coming out, and while we're getting that sorted out, I just thought I would give you a quick preview of things to come. During July, we are closed for maintenance, but if anybody is handy and likes to help out with things like that, we'd love to have extra volunteers. It can be everything from the complex side of fixing the telescopes to the very basic side of we are unloading a big wagon full of crushed gravel tomorrow morning. But that's to help protect the land and the area around our big radio telescope. So we can, John mentioned the need for money, but we also very much appreciate donations of your time and talents. And so we have a really fun group of volunteers here. We have parties, we have all kinds of events, we have extra education programs. John, who was just speaking, is going to be teaching one tomorrow. What time?
10 to noon.
10 to noon, if you would like to learn more astronomy in depth. And then July, we are doing cleaning and upgrading here at the observatory. In August, our speaker is going to be about NASA's Orion spacecraft. And in October, we actually have our future speaker, Greg Worth, here, who is an astronomer from Keck Observatory, which is a very famous observatory, and who has moved to Longmont, and we're very happy to have him. Thank you. So are there any other events or announcements? Yep.
You can tell them how, if they wanted to
Do you want to stand there?
tell them how to book a night for their family and friends to come, and we'll be here to help you. You can stay all night and look at stars. All you have to do is go online
Starkids.org, the website's right up there.
and just book it, just enter all the information you want and show up. We'd love to help you. That'd be a lot of, it's great for birthday parties for kids.
There is a prerequisite of bringing clear skies to get the rest.
You gotta bring clear skies, that's right.
Yeah, and Carol is one of our favorite volunteers, and she throws fabulous parties. Other announcements? Okay, well, without further ado, we're going to move on to our main speaker for this evening. It's Dr. Suzanne Metlay. She is one of our most popular, long-standing, and beloved speakers here at the Little Thompson Observatory. I've lost track of how many wonderful talks you've given here, but June is kind of an annual event for having Suzanne come to speak. For those of you who haven't read her full biography or heard it from the past, Suzanne is a graduate of Harvard University and got her PhD in a combination of geology and planetary science from the University of Pittsburgh. And she's got to do cool things like research meteorites from Antarctica. So we might have to get another Antarctica talk at some point.
Get the other Suzanne as well, and we'll compete with slides of who have the better time on the ice.
So Suzanne has been the Education Programs Manager at this Planetarium at the University of Colorado at Boulder. She has worked for the Secure World Foundation, and right now she has the position of professor at Western Governors University, which is an online university which actually right now is graduating the largest number of accredited science teachers in the United States.
Andrea, thank you so much. Can everyone hear me okay? Or is it too loud? Okay, because I'll bellow, so you just let me know. If anyone does want to know more about Western Governors University, I have my business cards up here. You can come and talk to me later. I teach science teachers. And in fact, my specialty right now is earth sciences education. So we have both undergraduate, people who've never been science teachers before, and we have people who are already teaching, like biology or chemistry. They want to switch to Earth and space, but they've never had an astronomy course. So we teach them what they need to know in science so they can then go get their master's degree and get that bump up in pay. So if you know about anybody in that position, I'm happy to talk to you. We keep our tuition super, super cheap because we don't have a campus. You learn from home, I work from home, right? This is a private, non-profit. We get most of our money from foundations or companies like Hewlett-Packard. So WGU, Western Governors University, is not in it for the money. We're not making money off the tuition. So as I said, if you know an adult learner, that's who I want to talk to. So I want to thank everyone for coming out on such a beautiful night. Thank you. And I don't want to keep you inside. I do want you to be able to go look at the telescope. So I'm going to rely on Andrea and the other volunteers, whom I'm very grateful to. Yeah, I think it's been about 15 years since I started giving these annual talks, to make me shut up so you guys can go look at all the fun things through the two telescopes. You've got a 16-inch and a 24-inch. 18 and 24. See, I've been here 15 years, but I don't know these things. So you've got to talk to the volunteers because they know everything. And so, yes, thank you. This is a great community. And if you come on a regular basis, you will find you will become part of this fantastic community. And it's a joyous organization to be part of. Is there anything? Okay, well, since there isn't anything particular, I want to point out summer solstice is on Thursday. It is the longest day of the year. Yeah, so if you really like getting your vitamin D, that's the time. And if you, like me, think morning is evil, then I promise the sun will start rising at later and later times and we'll get back to a normal schedule. But, all right, so what I wanted to do today was talk to you about Colorado. And you're like, wait, that's not on the screen. Well, yes, it is. So when we talk about the solar system and exploring all the amazing worlds that we have, oh my gosh, who has built all this stuff? Who monitors it? Who maintains it? Who makes sure that we not only get the data, but analyze the data appropriately? How do we come up with ideas of what we want to do next, where we want to go next, and how are we going to fund it? Right? You can't always rely on NASA as much as, we would have liked to decades and decades ago. Things change. And Colorado plays an incredibly important role in answering all of those questions because the people who live and work in Colorado, about 15% of our workforce, 15% is in aerospace. think of the work, the value that these people produce. In fact, how many here work for Boeing or Lockheed Martin or Ball or do some other kind of aerospace? I can't raise my hand because I work for a university. Are you the only one, John? There have to be others. So there are others. They're just not here tonight.
I was raising my hand. He wasn't.
Okay. Well, a lot of us who do Earth and space science education rely every day on the work that people at CU Boulder and Raytheon and advanced satellite systems, right? Even if you've never heard of the company or the organization, you know the end product, which is incredible imagery of Earth and other planets, each one worthy of our investigation. And so what do? We go and we build more stuff. So if we can't go by ourselves, we can send robots, or we can get data from telescopes, like the radio telescope here, right? A fantastic tool for getting information from someplace you can't touch or can't even necessarily see directly. We can still do that work. So whether you're into geology or astronomy or computer science or any other field, maybe you're into art, we need graphic artists, because people who do graphic arts come up with diagrams like this, which is a diagram of our solar system. Now, I like this diagram. Oh, I have a question.
I see diagrams like that all the time in books, and you know that that's like really, really wrong, right?
Well, why don't you tell me why it's wrong? By the way, this is my husband, Mike.
Everybody, I'm Dr. Mike Metlay, formerly of the Orion National Laboratory, currently editor of Rock and Roll magazine. My exposure to citizen science these days is helping my beloved wife out with demonstrations like this. These diagrams are useful for certain things. They give you a rough idea of what a planet might look like from space. Sometimes they give a rough idea of how large one planet is, how small another planet is. But there are a lot of things about this diagram that are not accurate at all. And the problem is that a lot of us, especially the older folks in the room, we have seen diagrams like this in our textbooks ever since we were little. And what that does is, it gives us a skewed view of just what the distances in our solar system and in our universe are like. Now, one of the things that Suzanne loves to do, which I love to cover with these talks, is something called body astronomy. One of the easiest ways to have new ideas about astronomy stick in your head is to have people demonstrate them. So, I need 4 volunteers from the audience. 4. Anybody, please? So we have 1, we have 2, anybody else? Yes. And anybody else? Anybody else? Anybody? Nobody else? Nobody? Nobody wants to volunteer? Daniela. So good. All right. Thanks. Okay, so we have our 4 volunteers. Give it up for our 4 volunteers. Okay, now what we're going to do with our 4 volunteers is we're going to demonstrate first the size of the inner solar system, which is from the Sun to Mars. Then we're going to demonstrate the size of the outer solar system, from Mars to Neptune. Okay? Now, the unit of measure we're going to use, it's a pretty long way between planets. Astronomers like to use, when we're talking about planetary distances, something called the AU. That stands for astronomical unit. Now, does anybody know what an AU is? Oh, well, we know you know, John.
Hang on, Mike, we're going to have to interrupt, because John in the back does have something he needs to show us that might help us with that AU. So John, if you can.
This is, if we were only one pencil, a tediously accurate scale model of the solar system. Now, John's going to get this going, and it's going to start running the distance from the sun, which is about this big, and it's going to start moving at the speed of light toward the Earth. And what you're going to find is that the distance from the sun to the Earth, light takes about 8 minutes. And that distance is 1 AU, 1 astronomical unit, which is about 93 million miles. Okay? So we're going to remember that, 1 AU. The distance from the sun, which is disappear, the Earth will show up there in about 8 minutes. So I'm going to entertain you with 10 facts. For those of you who like staring at black screens, there are humorous things down here. There, that was about 10 million kilometers just now. And you can check that out. But for now, my volunteers and I are going to give you a much more solid view of what kind of distances we're talking about. Now, we have 4 volunteers. We're going to start with the sun. Now, the sun needs to be big and massive.
That's me. Here's my sun hat.
Okay, so our sun is right here, right? This is where we start our measurement. Now, we need a planet to put in front of the sun. How about holding on to you for later? How about you? What's your name? Maya. All right, Maya, I want you to stand right here. Okay? Now, everybody see Maya? She is standing in for the planet Mercury. Mercury is about 1/3 to 4/10 of an astronomical unit from the sun. About 3 light minutes. Okay? So, a beam of light from the sun takes about 3 minutes to get to Mercury. Now, Daniela, if you would, I need you right about here. Okay? Now, this is about, this is about 0.7 astronomical units. Can anybody tell me what planet Daniela is standing in for? Venus. Venus, yes, the second planet. Now, your name is? Karen. Karen, come over here. Stand right on the line. Nope. Here is our Earth. This distance, by the way, we've only gone 2.4 light minutes. We haven't even passed Mercury yet. So our beam of light traveling from here out to here takes 8 minutes. This distance right now from Suzanne to here is 1 AU. Now, most important person, because this is going to be the bridge between the inner and the outer solar system. Your name is Quinn. We're going to take a trip out to about here. Okay? Now you'll notice the distance between Quinn and Kerogen is a little larger. That's Mars. Mars is about 1.5 astronomical units out.
Here's Mercury. Yay! Okay.
Oh, we actually we made it to Mercury, but so hello Mercury.
Well, this frees up Maya to be something else now.
We can't. You know why we can't?
Why not?
Because on this scale, what we're seeing here is all very easy for us to take in. Does anybody want to guess where Jupiter is?
Outside.
Way outside. Now, what I'm going to ask is, I'm going to ask our Mercury, Venus, and Earth to step out, get out of the picture, because we're going to repurpose you to be different planets. And now you all have to imagine pulling the focus of our, we still need them, but we are going to pull the focus back so that this 1.5 AU shrinks. So Quinn, you're still Mars. This is still Mars. Come on. No. Right about there. Okay? About 18 inches. This is now 1 foot per astronomical unit or thereabouts. Okay? So actually it should be a little closer, but this is a family thing, so we're not going to be squishing together. Alright, so which would be our Jupiter? Okay, light takes 40 minutes to get from the sun to Jupiter. Now, in between here, between Mars and Jupiter, is the asteroid belt. About 2.8 AU. I'm not going to keep doing that.
Can you keep doing that?
All right, Daniela, come with me, please. Okay, put you right about here. No, actually, back a little bit. Here, yes. Now, after Jupiter, we have Saturn. Now, look at this scale. This is about 1.5 astronomical units. This is 5. Next planet out, this is 10. All right? Now think about what it takes to get to these planets, what it takes to explore these planets. We have sent a large number of craft successfully to Mars, right?
Jupiter, really large number unsuccessful.
Oh, yes. Actually, Mars is considered a cursed planet.
Venus.
Venus. Oh! Hello! Now, to get to Jupiter, considerably fewer have made it. The Juno mission is exploring Jupiter right now. Before that, there was Pioneer 10, Pioneer 11, the Voyagers. When we get out to Saturn, 10 AU, things are starting to get really difficult. We're looking at the limits of what we can do right now with a mission that can be placed and stay there and pick up a lot of information. We recently said goodbye to a tremendously successful satellite called Cassini, which moved around the Saturn system, took pictures of Saturn's moons and its rings for many, many years. Very, very successful. Okay? Now, it doesn't look anything at all like that picture we saw where everything seems to be in even doses. Now things get better. Carrie Lynn, Will. Right about here. Okay? The next planet out is Uranus. This is 20 astronomical units. We have only managed to send a flyby once, twice. Once. Okay? When you get out here, things are getting really hard. Okay? We've just, from this distance, we doubled it to here. We doubled it again to get to Uranus. Okay? Now, we're now far enough out in the system, so I don't need somebody marking Mars anymore. So Quinn, if you'll come with me, please. Come on. 10 AU, 20 AU, 30 AU. Welcome to Neptune. Okay? Now remember, all the way back here.
Hello.
Oh, and there's the Earth and the Moon.
Excellent. Let's stop this, John, because we have another Earth moon.
But I have one more thing I'd like to point out, if I may.
Go ahead.
But first, Earth wants a kiss. Now, here's the thing, folks. You've got an idea of how big the solar system is, right? So, if anybody want to make a guess as to how far the nearest star is away from the sun? I'll show you. One moment. Okay, can everybody see Long's Peak? Long's Peak from here is 51.2 statute miles. On the scale that we're using for the outer solar system, that is 4.25 light years. So the nearest star to our sun is about where Long's Peak is. Okay? So this is the farthest planet we've seen. Pluto a little farther. It's technically not a planet.
It's a dwarf planet. It's a planet. It's smaller.
That's why it's rock shield gave another.
It doesn't fit in the building anymore. That's why.
Yeah, but every couple hundred years it does again. Yeah, it's like me, it's eccentric. Quinn, Brilliant, thank you. Carrie Lynn, thank you. Danielle. That gives you an idea of what we're really talking about. And this is the reason why we know so much about Mars. We've had so many missions there, and we have a fair amount of information about Jupiter and even Saturn. But when we look at the farthest reaches of the solar system, it's really, really hard to get there. And when you get there, you're moving so fast that it's basically, with our current technology, impossible to stop. So you gotta take pictures as you go by, which is why we only know as much as we do about Uranus and Neptune and Pluto. But in the future, they are talking about doing a long-term Uranus mission. They don't know when it's going to launch, 2032, I think. But anyway, that gives you an idea of the scale we're working on here. And the important point of all of this is that every single place I mentioned, except for Lawrence Peak, Colorado has sent spacecraft.
Thank you, Dr. Metlay.
Thank you, Dr. Metlay.
John, would you like to move to the next one? This is called From the Moon to the Earth. And I'm going to need Daniela, Maya, and Quinn again.
Yes, thank our volunteers.
Yes, thank you, Carrie Lynn. Because I'm not going to make you necessarily model anything out. But if we get this started, John, you may want to, yeah, there you go. Scroll gently. We're starting at the moon. And a lot of people want to know, if you're on the moon, can you see any of the spacecraft that humans have put in orbit around Earth? What do you think? If you were an astronaut on the moon, could you see any of that stuff? No, you're not. You're shaking your head, and that is the correct answer. No, the moon is too far away. And if you were on the moon looking back at Earth, you wouldn't see any of the satellites or other stuff that we've put here, even though we've got a lot of stuff between us and the moon. It's just that the moon is really, really far. And that's why it's been very difficult to get other spacecraft back to the moon, let alone humans. Of course, there's also the matter of, do you want to, that's cute. Do you want to send a person through the Van Allen radiation belts and all the other stuff you have to get through to get to the moon? I love that factoid, by the way. The moon really is moving away from Earth. This is because of orbital dynamics, also because of an energy exchange between the Earth and the moon. Earth and moon are not a dynamically stable system, meaning we're still exchanging energy and we're still dancing with each other in such a way so that Earth is going to slow down a little bit and give some of that energy to the moon. So the moon can pull further away. Notice we're what, 125,000 miles above sea level. We're looking at this interesting breathing asteroid. I don't know why it's growing bigger. The asteroids don't do that. Have I talked right past geostationary?
Nope.
I didn't think so. I thought I was on my way. So Daniela, you are going to represent geostationary Earth orbit. So if you'll come over here, please, and do your very best satellite imitation. You can decide what you think a satellite is. Yes, satellites do that. Satellites will rotate. Thank you. You are done. No, I just don't want you to get ill from too much rotation. So a geostationary satellite, can you tell me what that might be?
Something that studies rocks.
Something that studies rocks. No, something that stays in the same place over one particular place. So if you wanted to always take pictures of Little Thompson Observatory in Berthoud, you'd want your geostationary satellite to be in an orbit so that as Earth turned, the satellite would move right along. So why don't you pretend that the table is Earth and pretend it's rotating. Go ahead and walk around it slowly. And that is how the satellite always stays in the same place around that one particular spot on Earth. Thank you, Daniela. So there are lots of good reasons why we want to have spacecraft there. They can do an awful lot with communications. They can do an awful lot with, TV. Boy, how many of you watch TV? Actual television with signal. Okay, you rely on those geostationary satellites so that especially if it's a live event taking place, let's say you're watching the World Cup in Russia, you're relying on the geostationary satellites to bounce the signals to you in real time. Hey, we finally got to geostationary. Notice how long it took us to get here. We started at the moon and I had to do all that talking, waiting to get here. So this is a really important part of our satellite components, but what happens if one of the satellites gets injured, right? Maybe a meteorite hits it or a piece of another satellite hits it. Sometimes we've got to move the satellite into what's called a graveyard orbit, because if we don't, it's just going to stay orbiting in geostationary for as long as it possibly can, being a hazard to other spacecraft. So we do have to actually sometimes nudge it out of its orbit so another operational satellite can take its place. Any questions or comments? Then let's move on to medium Earth orbit. I promise we'll get there faster. So Maya, you're going to be medium, because Maya, medium, get that? Okay, I apologize for the bad pun. What kind of satellite do you think is at medium Earth orbit?
One that studies meteors.
One that studies meteors. That would be a good answer. Actually, how many of you have GPS in your car? Okay, you can thank Maya and the medium Earth orbit satellites, which help you with your global positioning systems and navigation. No, we have lots of things to study meteors, but they go by too fast for the satellites, and sometimes they hit the satellite, and that can be a problem. So yeah, we got to medium Earth orbit here. And you can see that this is also the edge of what are called the Van Allen radiation belts. Van Allen was one of the first American researchers to look at the space between Earth and the moon back in the 1950s. All right, let's keep going. Okay, now, Telstar. We have weather satellites in this area as well. Okay, so now it's getting really, really crowded, isn't it? Come on, Quinn, join the party. Make it crowded, because you are low Earth orbit. I'm short too. So low Earth orbit. And you know what? This is actually inside Earth's atmosphere. A lot of people think that when you see the astronauts in the International Space Station that you're really super far away. You're only about, 250 miles directly up from where we are right now. And if you think 250 miles from here, somebody want to shout out a location?
North Platte, Nebraska.
There you go, North Platte, Nebraska.
Trinidad, Colorado.
Still in the state of Colorado. Yeah. Anybody else?
Gunnison, Colorado.
What was that?
Gunnison.
Gunnison. Thank you. So this is where all sorts of interesting satellites are. Have you ever used a satellite image of your own house? Have you ever looked at those Google Earth images, right? These are the ones from low Earth orbit, which is inside Earth's atmosphere. But above what's called the Kármán line, back in the 1950s and early 60s, they thought that if you got above 62 miles, which is about 100 kilometers, that you would be in space. And then, of course, we started putting more and more stuff there and realized, oh no, we're not in space. But if you want to be an astronaut, all you have to do is fly past 62 miles and you qualify. So right now, it's a fairly select group of people around the world who've been able to go more than 62 miles away, going straight up. But hopefully in the next few years, that will change, and a lot of you will get the opportunity to go as space tourists. So I want to thank low Earth orbit, medium Earth orbit, and Geo, sorry. So, in other words, Daniela, Quinn, and Maya, thank you very much. And if you don't want to be a pilot, you can always be like Felix Baumgartner or Alan Eustace, and you can just jump out of a stratospheric balloon, which is pretty impressive. Okay, so I think we are done with these and we'll actually get to tonight's talk. Any questions or comments before we do that? Yeah, go ahead. Questions? All right, well, I have one. What is aerospace? That's kind of a big word. I'm not hearing shout, so I'll just answer it. Airplanes. This is Colorado 1. Thank you, Southwest Airlines. Of course, spacecraft and satellites. Greg, you can tell us all about the Orion Project. This is the assembly building in Florida. So that's from a few months ago, right? Okay. And if you have a drone, please don't fly it where emergency personnel are trying to put out the wildfires. Just don't. But the entire drone industry is growing. RTD is using drones to check its rail lines across the Front Range. So we're looking at around a $100 billion industry, just the drones, in the next few years. You can imagine the amount of revenue that this brings in for the state of Colorado when you put all of this aerospace together. Now, I'm going to do a bit of a history lesson, but before I do that, I just want to point out that this is like the coolest photograph for me, because you can't read it, but it says the Air National Guard, that's what this is, just in letters, so ANF, offers careers. Enlist now. And I was also interested in what was coming out of the back of the plane. So these are bales of hay that they were dropping in 1949 because, as you can read, there was a blizzard and the farmers couldn't get out to where the cattle were, and they wanted to make sure that all the cows and sheep and pigs had something to eat, or at least something that they can stay warm with. So they were dropping bales of hay to keep the cattle comfortable, which I thought was really nice. By the way, Colorado Civil Air Patrol is still around. My daughter Julia was a member. She got to the rank of cadet lieutenant. And so I will always support anybody who wants to do Civil Air Patrol, Air National Guard, whatever it is that you do for public service. Thank you. And if anybody here is a volunteer firefighter, really, thank you right now. Anybody have any stories to share? Okay. So back in the days of dropping hay bales was something called the Cold War. Now, I always say it ended in 1989 with the fall of the Berlin Wall. Old people will know what that means. Young people, you'll learn. But others pegged the end of the Cold War with the collapse of the Soviet Union back in 1991. Either way, it was a long time ago. But it was a really, really big deal. I mean, look, that was pretty much the last half of the last century. And for a lot of us who were trained as Cold Warriors, it was a big part of our lives. When I was at Harvard, I was with the Russian Research Center for one summer. And this was serious stuff. And it was always interesting when I would take a class with, say, Richard Pipes, and he would say, "Excuse me, I have to leave class early. The president is calling." Because, in fact, President Reagan would call him. And he'd have to leave class and go advise the president. So, yeah, that was a really weird undergraduate experience. Anyway, the whole thing was that the United States represented capitalism, the Soviet Union and its allies represented communism, and there was something as a result called the space race. And if you think this doesn't affect you, has anybody heard of North Korea? This is why there's South Korea, ally of the United States, and North Korea, which back in the day was an ally of China, which really back in the day used to be an ally of the Soviet Union. So this does have repercussions even now. The way it affects us in Colorado is that a guy named Glenn Martin had started up a little aerospace company, which later became Martin Marietta. Anybody knows what it's called now? Lockheed Martin, right, one of our biggest employers. And he decided to actually sell his company to somebody else who decided it should come to Littleton in 1955. Ball Aerospace followed very quickly after that, and then all the US Air Force bases and military facilities. So if you look at this map, let's see, Berthoud is just about here between Loveland and Fort Collins. Here's south of Loveland, sorry about that. And then Longmont, right, where a lot of us live. But notice that it's Lakewood, Aurora, Boulder. This was the initial space community, but then it moved down to Colorado Springs. So by the mid-1960s, while the space race was really going on, this is when the US Air Force Academy came here, Cheyenne Mountain came. Anybody know what Cheyenne Mountain is famous for?
War games.
It's famous for NORAD, and of course, every December, what does NORAD do?
Track Santa.
There you go. But they started out tracking Titan missiles and other less pleasant things. So we're really happy that they're spending their time tracking Santa Claus instead of this other scary stuff. Now, to be completist, there are, there's a big Army base in Colorado Springs called Fort Carson. There's also a chemical storage facility in Pueblo. So when you look at this, you'll notice that all the military and aerospace facilities are pretty much along this I-25 corridor. And there are a lot of these facilities now. This is just a tiny sampling of the organizations that do aerospace work. Everything from, Boeing, who makes airplanes and space equipment, to Secure World Foundation, which is a nonprofit I used to be operations director for. There are private corporations like Digital Globe in Longmont and Westminster, and then, lots of other organizations who do stuff. Anybody who's going to go to CU Boulder or is at CU Boulder as an undergrad, you can get some funding through the Colorado Space Grant Consortium, get your own hands-on experience building a little CubeSat or other satellite, which you will then launch and you will then monitor and maintain in orbit. This is something undergraduates do. So why not you? Especially you. Yes, you. You can do that.
Do it.
And you should. When we look at Colorado Aerospace, there is a lot of money here. Not only because we've got all that military presence, but we've got lots of private and nonprofit, 25,000 people. These are 2017 numbers. So 25,000 people last year just employed by private companies, let alone everybody else. As I said, graphic artists, accountants. If you have an English degree, we need you to write copy, because goodness knows the engineers can't do it. And if you look, not only is there a lot of growth, the average wage for an aerospace engineer is nearly $130,000 a year, which is not bad. I would love to make that someday. I would love to get close to that someday. When we look at where the aerospace engineers are in the United States, they're clustered. And the darker the color green, here's our cluster, then the more people in that field. Anybody want to guess why we have some of these clusters where they are? What was that?
Diversification.
Diversification, yeah. This is a map of where the NASA facilities are. But it's not a direct correlation. For example, there's this cluster here in Washington State and Oregon, and there's no Washington State or Oregon NASA facility, but what is in Washington State or Oregon? Well, especially Washington near Seattle. Boeing and Microsoft. Yep. And you better believe Amazon is looking at this and going, I wonder. Yeah. The other place that I think is interesting is, if I can, this is Metro Atlanta. There's nothing in Metro Atlanta on the NASA map, but there is a cluster of high-tech companies here. Also the Research Triangle in North Carolina and others. So you're going to find that there are these pockets of commercial activity that are not necessarily reliant on government contracts. These are companies that are popping up on their own, or well-established companies that have decided aerospace is worthwhile. And of course, where you have a big company, you're going to have lots of little companies and lots of innovative startups. You also want to look at where you have universities, because that Atlanta cluster is probably tied to Embry-Riddle, one of the premier aeronautical universities in the United States. So look for your universities, look for well-established tech companies, and you're going to find aerospace startups. Now, here's the thing. U.S. citizenship is required pretty much because federal contracts require it. So even if you're a private company, if you decide to work with the state or federal government, you probably have to guarantee that you have U.S. citizens, which can be tricky for a lot of our friends and neighbors who are not yet U.S. citizens. It's why it's important to pay attention to how do we help really talented young engineers and scientists get their citizenship so they can be part of this. There are national security concerns, of course, but you know, if we're talking private companies that are not beholden to federal contracts or not doing national security work, then these citizenship requirements could go away and we could open the door to a lot of talent if the visa programs and other policies allow us. That's not part of this talk. I don't want to get into politics. I'm just saying that not everything is government run, and I think that's a good thing because that opens the door to a lot of innovation and flexibility that we don't have elsewhere. Of course, the United States is not the only game in town. Aerospace is international, and the Europeans, what they're calling United Space in Europe, they've been at this for 50 years. And the European Space Agency routinely has astronauts on the International Space Station. Quite often a crew will have one American, one Russian, and one European. Not always, but that's the usual crew lineup. Of course, there are others. India has been doing terrific work on the moon, right? You never hear about it. We only talk about American organizations, but we do need to broaden our view because we are not the only spacefaring country. In fact, if I'd wanted, I could have made a wall of logos of international organizations, quite often government affiliated, but not always, that are doing work. But where I really wanted to spend my time on this slide is China. China just deorbited, meaning crashed, its older space station, which was meant to be a test. And on that older space station, they did have some all-male crews, and then finally they allowed a woman to go up. Ooh. That was like 7 years ago, maybe 8. So it's time for them to make another space station, and they think so too. And looking at the success of the International Space Station, which China was not allowed to be part of, to the point where they could not even have their space station in the same orbital plane as the International Space Station. So if you saw the movie Gravity with Sandra Bullock, no, sorry. She wasn't going to get any help. But, so Yeah, but she was able to get onto first a Chinese space station and then a Soviet space station, and it's like, no, 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 no. Anyway, that's okay. That's why movies are fun, because they can come up with all sorts of things that can't happen in real life. And don't take me to see Jurassic World. I will talk to you about feathers on dinosaurs for 90 minutes afterward. But China really, really does want to set up a new space station and wants it to be fully functional by 2022. That's not very far from now. We're already in 2018. So they want partners. Just like there are 15 or 16 other countries that are working with the United States on the International Space Station. That's why it's called international. China wants to do the same thing. And since the United States is not always good about making or keeping its friends, a lot of people are going, China. So you might see some activity on this from countries or organizations you didn't expect. Obviously, no news yet. They only announced this initiative a few weeks ago. So we'll stay posted. So bringing it back to Colorado and things we do know about. First off, shout out to the people at Ball Aerospace. They build phenomenal equipment, and their stuff is all over the solar system doing superb work. In fact, they did an awful lot with Hubble Space Telescope and did a lot of the initial design and all the rest of that. Hubble is a whole nother talk. Not going to get into that. But what they're hoping is the James Webb Space Telescope, if it ever gets launched. I've been talking about the James Webb Space Telescope for 20 years, always saying, in about 5 years, it should launch. Which means part of the James Webb Space Telescope is 25, which is more than twice the age of some of you here. Yeah, I'm not holding my breath on James Webb. But it is coming, but I'd rather look ahead to W first. And this stand, I can't remember. Oh, here we go. Wide field, meaning it's going to look at a really big array of stars. Infrared, which is part of the electromagnetic spectrum. But here's a better way of thinking about it. Have you ever been at a campfire? You don't want to touch the flame, do you? Why not? It's hot. Well, you're feeling infrared radiation. All that heat on your skin, that's infrared. And so we can, with our telescopes and satellites, look at or feel that infrared and use that data to get information, again, about the stars and other objects we cannot touch. And it's a survey telescope, so it's designed to look at things and not necessarily know what it's looking at. It's gathering information. And for that, you need a wide field instrument, which is what Ball Aerospace is going to make. And yeah, they were given this award at the end of May, so about 3 weeks ago. Sierra Nevada, anybody know about that? Okay, well, how about you? You want to tell me about it? You've just heard about it? Yeah. Okay. All right, John, what can you tell me about it?
Mark.
I'm sorry, Mark. There are so many Johns.
They're working on that Dream Chaser aircraft, so you'll have more information on that than I will.
I'm sorry, go ahead. Go ahead. Do you want the microphone?
The basis in Colorado, the Sierra Nevada, was this little startup called Solstice in Boulder, and they made actuators to release spacecraft into from the rockets and everything else, and that over the years they've been bought by other companies and everything else, and now they're part of Sierra Nevada, so they're a growing company.
All right, I'm gonna try to. Thank you. I'm gonna try to get close to you so I can give you the microphone because you were gonna say something.
Oh, no, that wasn't me. That was someone in the back.
Somebody else want the microphone? I don't think I need the microphone, but I'll keep talking into it. So, the Dream Chaser, I have to admit, when Mike looked at this, he said, "Ooh, is that the Buran?" Which was an old Soviet-era version of the space shuttle. And the Buran actually did fly a few test flights before it got retired and put into a museum. So this is sort of a much more modern, much more functional equivalent. This is really a remote-controlled plane, so an autonomous space plane. It flies itself and has successfully done test flights. So this is really what it looks like at Edwards Air Force Base, and it's very exciting. So it should start making runs, reusable runs, for cargo delivery to the International Space Station, hopefully starting next year, maybe the year after. I think that's awesome, right? Because right now we've been using SpaceX, which is also great. We've been using the European ATVs, autonomous transfer vehicles, but those burn up after 1 or 2 uses in Earth's atmosphere. And these are reusable, which is way better. Yes, sir?
Is this a NASA project, or who is this a private company?
So Sierra Nevada Corporation is a private company. As Mark explained, these private companies grow by swallowing other smaller private companies, and they get bigger and bigger and bigger. And so this is a private company that won a NASA contract. But eventually, they're not going to be looking to NASA as the big place to make money. They're going to be looking to Amazon and other places, right? So you start with NASA or some other government organization, and then you wean yourself off the government and onto other private sources of funding. Okay, Lockheed Martin had so many things that I could have been here for another 10 minutes talking to you about Lockheed Martin. And I thought about that, and I was like, no. I'll just stick it all on one slide with too many words and no pictures, so we're going to move on. Lockheed Martin is doing a lot of really, really good stuff. And you're going to talk about the Orion Crew vehicle in October, or is it August? No, I can't remember. It's October, isn't it? Yes. Okay. So the one, of course, I am most excited about is the one at the bottom, OSIRIS-REx. This is an asteroid sample return mission. And for those of you, oh, you're all brand new. Well, I'm just going to have to come back next June and talk to you about OSIRIS-REx because my specialty is meteorites. I went to Antarctica as part of the Antarctic Search for Meteorites, where my little field team, we've collected 1,000 samples in one field season. A field season is only like 8 weeks. So, we added 10% of the world's known population of meteorites back in the day. Now, of course, other people have done other amazing things. There are lots more meteorites to be found at the bottom of the ocean, tops of mountains, other icy areas. And so here we have OSIRIS-REx, who's actually going to go to an asteroid. And we're going to be able to compare the real stuff from a real asteroid to the stuff that I collected in Antarctica. I cannot wait. So, yeah, come back next June. It'll be a much more vibrant discussion. So here's, I think, my favorite slide. We're going to hopefully get something called Spaceport Colorado by the end of this year. Now, right now, it's not much. Front Range Airport is this little tiny dirt strip in Adams County. And here's this fascinating poster, very aspirational, implying that you can ski your way to space. I don't think so. It would be fun. Actually, you really want to ski one of the glaciers on Pluto. That would be so cool. But in the meantime, here's a map of Adams County on your left, and you're heading toward Kansas on the right. And there's Nebraska just north of where it says ignition. So you've got the Nebraska-Kansas line right near Colorado. So you can see that this is a huge swath of eastern Colorado. And that's where they'd like to put this thing for space planes, like the Dream Chaser, to take off and land. Yes?
I like the oops area.
Oh yeah, the oops area. No, it's actually ops for operations, but it does look like oops. Yeah, it does. I had to stare for a minute at this and go, what the heck? And then I realized, oh, ignition is when you're on your way in, this is where you want to light your engine. So you come in, but then you got to loop around so you can actually get on to the runway and get to the airport. But yeah, the whole idea is the way we fly back and forth now, remember 100 years ago, very few people knew how to fly airplanes. And the ones that were flown were used in World War I for military purposes. It was only after World War I ended in 1918, exactly 100 years ago, that people said, but we can use airplanes for all sorts of other stuff, like maybe dropping hay bales so that cows won't starve. And it would totally boggle somebody's mind from 100 years ago that we can just take a plane and go anywhere around the world. So wouldn't it be nice to have our own spaceport, go into low Earth orbit for a couple hours, look at Earth, chill? That'd be a great anniversary present, wouldn't it? Or somebody's birthday present. You know, let the rich people practice and spend their money because the costs will come down. All right, think about it. Jet aircraft 50 years ago. Anybody who's a little, past my age, anybody remember getting dressed nicely to go to the airport? It used to be a big special deal. You had to be well dressed. You had to put on pearls and high heels. If you were female, if you were male, you were on your own. No, everybody wore suits and ties anyway in those days. But that's the point, right? And you had someone who took care of you, an air steward or stewardess to attend to you. Now they're called flight attendants, and you can't even get peanuts because people are allergic. So the idea of having horizontal launch land vehicles, meaning airplanes, in this case, let's call them space planes. And when they're at the top of their orbit, not only will you have a nice view, but they can deploy payload. Hopefully not your luggage, hopefully the satellite that somebody has paid for to be put into low Earth orbit. Well, right now, this is a quote from USA Today. Spaceport Colorado is not much more than a dream and some paperwork. Although traditional flight schools and private pilots use the airport's long runways. So this physically exists. It just doesn't have the certification. It doesn't have the okay from the legislature and the governor. Of course, we're getting a new governor after the November election. So your choice at the ballot may affect Spaceport Colorado's future. So yes, you do have a direct role to play here. Now, CU Boulder's been at this forever, it feels. Back in the 1950s and 60s, they were right there at the beginning with Ball Aerospace and Lockheed Martin and Raytheon and others. So yeah, they're the #1 recipient of NASA funds. And if you get a degree in aerospace engineering from CU, yeah, you got some serious cred. But here's the bottom line. If you want to explore this world, other worlds, worlds beyond our solar system, because there are exoplanets and exosolar systems, meaning planetary systems orbiting stars other than our own. You can get there. Even if we don't have the technology now, you can be part of the people, the crew who build it. So this is my last full slide. Where is New Horizons now? It is almost at its next target in the Kuiper belt. So of course, thanks to our volunteers, we got as far out as Neptune, A little past that is Pluto. And notice, and New Horizons got there in July 2015. So now it's on its way to what's called a Kuiper belt object. And yeah, it's got this designation. Anybody remember the new name it was given? I'm having a, what was that? Yeah, I can't remember the name of it. It's like Ultima Thule or something like that. Somebody want to look it up on Google?
Was it on your earlier slide? The internet connection is down there.
Oh,
Was it on your earlier slide?
I don't know if it was on my earlier slide. It might have been. Do you want me to? It is not Makemake, because that is a dwarf planet just beyond Pluto in the Kuiper belt. But sharp eyes, I like that. I think it's Ultima Thule. Ultima as an ultimate, and Thule, which is a, if I'm remembering, a Nordic goddess, or just pointing to the north, and this is toward, I guess, our galactic north. So yeah, you're going to be hearing an awful lot about this over the next few months, because it should get there around New Year's Day. So we're talking 6 months from now. I know. I love the fact that this is all happening in real time, right? We're not talking James Webb Space Telescope. This will come eventually.
2 years, come on, hang in.
We're talking things that you can participate in by coming back to LTO, hearing more talks from more people who know more about these things than I do, because they are building the spacecraft, or they're doing the analysis. Daniela, did you have a comment? Did somebody else have their hand up? Okay, so I want to thank you. If you want to track down any of my data, the teeny weeny print is here. But really, feel free to email me. Again, you can come up to the front and grab a card. Let me know if there's anything more I can do for you. I promise to come back next June with some pretty eye candy. Thank you.